Hey guys, so here's some practice questions to do before your quiz. And so if you guys want to do these ones first, then watch this video to check your solutions. But either way, choose what you guys want to do, but just know that if you do it yourself, it'll help you to know what's going on, or it'll help let you know if you're ready for a quiz or not, okay? So here for this first question here, it says to express each expression in the opposite form. So if we're given exponential form, we're going to put it into logarithmic form and vice versa, okay? So this first one here, we have 8 to the power of negative 2 is equal to 1 over 64. And this here is in exponential form. So now we want to write this one into logarithmic form. And I'm going to write up top here, we have Ben the log bunny, so we have b to the power of e is equal to n. And that is Ben the log bunny, so we have log b n is equal to e, so we have bunny. So you guys remember that. Hopefully it should help get you through this. So here we have 8 to the power of negative 2. So here your 8 is b, e is negative 2, and n is 1 over 64. So we're going to write this into our logarithmic form. So we have the log of b, which was 8, n, which is 1 over 64, and that is equal to negative 2. Alright, so just like that. Here in b, we have y is equal to log 5, 1 over 125. So here we're given logarithmic form, now we're going to go into exponential form. So looking at log b and e, here our base is, or b is 5, n is 1 over 125, and here e is equal to y. Okay, so putting that in, we have b is 5, your e exponent is y, is equal to 1 over 125. If you guys want to, you could try, if you guys want to try solving these, you guys should be able to come up with some, or you should be able to come up with an answer here. But you guys don't have to, but if you want to, sure, let's give it a shot. So here we have 5 to the y, and let's change this into, we'll change this so it's not a fraction. So we have is equal to 125 to the power of negative 1. Then we change, we want the same base, so then we can just look at the exponents. So let's rewrite 125. So you guys remember that 5 cubed is equal to 125 to the power of negative 1. Then we have 5y is equal to 5 to the negative 3. Then we have the same base, so y is equal to negative 3. So I just threw that one in there. Actually, I just kind of came up with this one on the spot there. So, but it's always good to, I guess, to know. But really, all that this question required was this. But for those, if you really want to try solving it out, that's exactly how you would do that. Okay. So we're moving on to question number 2 here. So number 2 here says that we need to write the equation that corresponds to the following transformation. And they gave us this base log, which we have y is equal to log base 3x. And so here they gave us some parameters or some transformations that happens to log base 3x, okay? So here, the first one here, it says it's a vertical stretch by factor of 1 over 3. And if you guys remember, what does a vertical stretch, or where does that apply to? And if you want to start off by saying, well, we have, I guess, what is your general form of your log function? So we have y is equal to a log of c b x minus h plus k. So here, I guess looking around here, so what parameter would vertical stretch by factor of 1 over 3 be? So if you guys remember that, this here is your a, so that they're saying that a is equal to 3. So that's this value here. Okay. Then we're translating 2 units to the left. And that right there, so 2 units to the left, if you guys remember, that is affecting that x value. So it's going to be your h. So h there is equal to negative 2. It's negative since we're moving left. So if you were to look at that on a number line, say we had negative 1, 0, and 1. We're moving to the left. So just like on a number line, your numbers are getting smaller. So moving to the left would be negative. So that'd be putting it in place for h here. Then the last one here, we have to translate 3 units down. And if you guys remember, translating 3 units down, that's affecting that y value, so it's going to be our k here. And we're moving down, so that means that our k is equal to -3. So it's negative because we're moving down. If you're thinking about that y-axis, it starts off, say we had 1, 0, and let's say -1. So it's moving down. So think about that in your as your axis. So we're moving down, so that y value is getting smaller. It goes from 1 to 0 to -1. So the values keep getting smaller. Okay. So from here, we're not given a b value. It doesn't say that there's a horizontal stretch. So for now, this is what we have. So let's put this into our base function log base 3x. So we have y is equal to a, which was 3, log of c, which was, we were given in the question that it's 3. B was 1, so we don't have to write 1 there. And we have x minus h value, so b minus -2, or we can just say +2. And then plus k, which will be plus -3, or we can just write -3. Okay? So we're not given anything else in that question, so that's about as far as we can, or I guess as much as we can do for that question. So with that, we are done. Question number 2. Moving on down there, number 3 here says to given that following graph below. It's been translated. The original base function here was y is equal to log base 3x. So actually we're working out with that same one in the previous question. And so for this one here, we need to state the translations. Okay. Alright, so just looking at this question, this one's actually pretty nice. Here we only need to state the translation, so whether or not it moves up or down, left or right. And so it's kind of nice that way because basically what this kind of hints is that there's going to be no stretches. All they want to know is what are the translations that happen to this original function to get this one over here, the solid line one, okay? Alright, so for this one here, basically what we're going to do is, since there's no stretches, let's look about where, I guess, where some common points would be. So if you notice here, you can go along there, but this one here is at 1 and 0. And if you're going to look for that same kind of characteristic in your other logarithmic graph that they give you, I guess where you would look at, it's a little bit hard to see there. Sorry, I'll see if I can click out of there and make it go away. There we go. Oh, or not. Okay, cool. There we go. That's a little bit nicer there. Okay, sorry about that. So look about where does that look like the same point in our other graph? And if you look there, it looks like it'd be right about here. But if you wanted to double check, try with the second point. So then here we're at, this one here is a pretty nice one. We're not done with any decimals, so it looks like that's about 3 and 1. And if you notice, this one goes up or to the right 2 units and up 1. This one goes to the 2 units to the right and then up 1. Alright, so you notice that it has that kind of same little jump in those steps there. So then from here, as long as you can kind of confirm that these 2 points here, they're approximately, or they should be, I guess the same if we were overlapping those graphs, then what we can do is, so we're going to look at those coordinates. We have 1 and 0 goes to 3 and -5. So to ask yourself, what do you do to x? Or how does it change? It goes from 1 to 3. So that there we're doing x plus 2. So it goes, you add 2 to 1 to get 3. So that right there is, we're translating 2 units to the right. Okay, so that's for that first one there. So then let's look at the y. So we go from 0 to -5. So here we would have to go y minus 5 to go from 0 to -5. So this one here is saying that we're translating 5 units down. Okay, so from this, just from looking at one coordinate from each graph or each function, we can tell this. Then what you can do is we can do a check. So what we can do here is, we had two other points. We had 3 and 1, and then we had 5 and -4 there. So then do your check. So how did you get from the first x value to your second? So you went x plus 2. Then going to your y, how did you get from 1 to -4? Well, that was y minus 5. If you notice, those two match. So x plus 2 and y minus 5, that is exactly what happened with both of those coordinates. So that means that we translated 2 units to the right and then 5 units down. And then one way that you guys can is to put these translations into, say your transformations into your log function, and then put this into your graphing calculator and see if these two actually match. So I guess what you guys would do is, that'd be y is equal to log of 3 bx, and you're translating 2 units to the right, so that affected your x value, so that'd be, I guess that'd be your h is equal to 2, so it'd be x minus h, which was 2, then plus your k value, which was translating up or down, k there is equal to -5, and then so you're going to put this into your calculator and check to see if it works. So there's 2 different ways that you guys can check there, okay? So that should be hopefully good enough review for your quiz, so whenever you guys are ready, you know where they are.